Good day to everyone. This day we'll talk on probability. So there are learning objectives that each of you must be able to attain by the end of this lesson. You should be able to describe probability, and you should be able to solve problems involving the concept of probability. Make sure you have with you a notebook and a ball pen to follow along as we go along with our discussion. Now suppose that you were to pick a card from a standard deck of cards. What is the probability of getting a queen? So suppose you have this deck of cards, and then again you were tasked to pick a card from a standard deck of cards. What is the probability that you will get a queen? And then based on the previous activity, what can you say about probability? So when you say probability, the probability of an event is just the likelihood that the event will occur. I mean to say, what are the chances that this event will particularly occur? And it also refers to the chance that the event will occur, or again, what is the chance that this particular event will occur? So we say, what is the chance that tomorrow is going to be a sunny day? That's a probability. And then basically, to compute for the probability, we use this formula. The probability of an event E to occur is equal to the number of events in event E divided by the number of events, or the number of uh, this is the number of elements an event, or in set E divided by the number of elements in our sample space. So this is the general concept of probability. We are going to determine how many elements are there in your event, in your sample space E, and how many elements are there in your sample space. And that's the probability. So let's try some problems to apply this concept on probability. For example 1, 3 coins are tossed. So you have there 3 coins, and then find a probability that 2 heads and a tail will come up. Now for example, we have here, you tossed 3 coins, and then you're tasked to determine the probability that 2 heads and a tail will come up. So take note that the ordering here matters. This is your first coin, second coin, and your third coin. So what is the probability that that it will show 2 heads and a tail? I want you to try solving this problem, then after which I'm going to show you the answer or the solution to solve this problem. Okay, I want you to show your answers. Let me show you my answers. So to do this, we have to determine the number of elements in our sample space. So as we have known, each of the coin can land in 2 different ways. And then since there are 3 of them and each coin can land on 2 different ways, then our sample space will be 2 times 2 times 2. That is 2 times 2 is 4 times 2 is equal to 8. So there will be 8 elements in our sample space. And somehow you can also enumerate what are these elements in your sample space, or what are the different ways in which these coins is going to land. It could be that all the 3 coins will show a head, 2 heads and a tail, 2 tails and a head, and so on. So you can enumerate what are the possible outcomes after tossing this coin, so that you will be guided to determine the event E in your problem. So that is again our sample space. Then from the sample space, you are going to create a subset of this sample space which shows 2 heads and a tail. So from our sample space, we have to pick out those elements which shows two heads and a tail. So this one, two heads and a tail, two heads and a tail, and then this one. So all the rest here, this one shows two tail and a head, two tail and a tail, two tail and a head, and then all of them shows a tail. So these are only the three events which qualifies our criteria that there shall only be two heads and a tail to show. So the number of elements in our event E is 3, and the number of elements in our sample space is equal to 8. Then from here we now have we can now compute for the probability of showing two heads and a tail when you toss 3 coins, and that is equal to the number of elements in event E divided by the number of elements in our sample space. The number of elements in event E is 3, and then the number of elements in our sample space is 8. Therefore, the final answer here is 3, 8. Or you can express it in terms of percent. But for accuracy, we have to make use of fractions because fractions are more accurate than presenting that in a percentage form due to rounding off of decimal values. We'll try example number 2. 2 dice are rolled. Find the probability that the two numbers that come up have a sum of 5. So again, 2 dice are rolled, so take note that each die can show in 6 different ways. So the sample space will be first die can land in 6 different ways, and then the second die can land also in 6 different ways. Therefore, our sample space here, or the number of elements in our sample space, should be 36. 6 times 6, that is 36. Now, I want you to answer this problem. What is the probability that the two numbers that come up have a sum of 5? Okay, I want you to start solving now, and then after which, I'm going to show you the solution. How do we compute for this problem? Take note, class, of the event A should have a sum of 5. From the sample space, you have to pick out those events which shows a sum of 5. Okay, I give you time to answer this one, then after which I'm going to show you my answer. Okay, let me show you now my answer to this problem. So again, you have to determine first the number of elements in your sample space. And then again, since every die can land in 6 different ways, therefore the 2 dice could land in 36 different ways. Thus, our number of elements for the sample space is equal to 36. And then from our sample space, you have to pick out those events which has the sum of 5. And these are 1, 4, 2, 3, 3, 2, and 4, 1. Thus, the number of elements for event A is equal to 4. So we now have this number of elements for event A and sample space. Therefore, we can now compute its probability. So the probability is computed as the number of elements in event A divided by number of elements in our sample space. The number of elements for event A is 4, and then the number of elements in our sample space is 36. Thus, when we reduce this fraction to its lowest form, it is equal to 1 over 9. Hence, therefore, we could say that the probability that the two numbers have a sum of 5 is 1 over 9. Questions or clarifications? Again, you just have to determine those events from your sample space. So it is necessary that you should know how to determine your sample space, because from the sample space, you can pick out those events. The same problem, but in different situation. What is the probability that the two numbers come up have a sum of at least 9? Okay, have a sum of at least 9. I want you to pick out those events from the sample space which has a sum of at least 9. And then after which, show your answers. And I can show you mine. Do you now have with you your solution and answer? Okay, let me show you the answer to this problem. So again, you have to determine the sample space. And as I've said earlier, that each die can land in 6 different ways, and then since there are 2 of them, therefore the total number of ways in which these 2 dice can land is equal to 36. And then from our sample space, we have to pick out those events whose sum is at least 9. So 9 is the minimum sum. So we have here 3, 6, 4, 5. 4 6, 5 4, 5 5, 5 6, 6 3, 6 4, 6 5, and 6 6. So these are the elements of our event B, which has a sum of at least 9. So you are going to count how many are these elements and then divide it by the total number of elements in our sample space. And the number of elements for event B is equal to 10. Therefore, the probability of event B is equal to the number of elements in set B divided by number of elements in our sample space. The number of elements in our set B is equal to 10, and the number of elements in our sample space is 36. Thus, it gives us a value of 10 over 36. And then again, we need to reduce this fraction to its lowest form, which will give us a value of 5 over 18. Or therefore, we could say that the probability that the two numbers come up have a sum of at least 9 is 5 over 18. Again, the only key here is to determine your sample space, and then from your sample space you have to pick out those events which qualifies the criteria as set in the problem. We now have different problem. What is the probability of getting 3 heads in 5 tosses of a coin? Okay, 3 heads in 5 tosses of a coin. So again, always remember that when you toss a coin, the coin can land in 2 different ways. And then since there are 5 tosses, so in how many ways, or what is the probability that it will show 3 heads in 5 tosses of a coin? I want you to try solving this problem on your seat, and after which we are going to show you the solution, or I'm going to show you the solution. Okay, let me show you now the solution to this problem. So in each toss, the coin can land in 2 ways. Therefore, if you toss the coin 5 times, it will be 2 times 2 times 2 times 2 times 2. Because again, every toss you have, the coin can land in 2 different ways. Either it will show a head, it will show a 10. So all in all, the number of elements in your sample space is 32. Okay, and then the number of ways that we can get 3 heads in 5 tosses is combination of 5 taken 3. So out of 5 tosses, we are going to select 3 heads. Again, out of 5 tosses, we are going to select 3 heads of those. So that is the number of ways we can get 3 heads in 5 tosses is combination of 5 taken 3 at a time. Therefore, to simplify, the probability in which in which we can get 3 heads in 5 tosses is equal to combination of 5 taken 3 at a time divided by 32, because 32 here is our number of sample space in our number of elements in our sample space, and then combination of 5 taken 3 is the number of ways that we can get 3 heads in 5 tosses. So to simplify, combination of 5 taken 3 at a time is equal to 10 divided by 32. And then further simplifying, we get the value of 5 over 16. Or in other words, the probability of getting 3 heads in 5 tosses is equal to 5 over 16. So again, take note of this. Getting 3 heads in 5 tosses is simply combination of 5 taken 3 at a time. 5 tosses, then getting 3 heads at a time. Questions so far or clarifications with regard to the solution? Okay, so to solve this problem, you have to identify first the number of elements in your sample space. So to determine the number of elements in your sample space, you are going to check how many balls are there in our box, and how many out of these balls, how many are we going to select? So that is combination of 14, since there are 14 balls in our box, and then out of 14, we are going to select 3. That is combination of 14 taken 3 at a time. Then what about for the number of elements for our sample space or for our event E? So the condition here is that the 3 balls will be all red. So how many red balls do we have? It is 6. There are 6 red balls, and out of 6, we are going to select 3. That is combination of 6 taken 3 at a time. And then from here, we can now compute for the probability of getting 3 red balls out of 14 balls in our box. So to show you the solution, so again, so the number of ways in which the 3 red balls can be selected is combination of 6 taken 3 at a time, and then the number of elements in our sample space is, since there are 14 balls, taken 3 at a time. So to simplify, the number of elements for our sample space is combination of 14 taken 3 at a time, and then the number of elements for our event E is combination of 6 taken 3 at a time. Then finally, to simplify, combination of 6 taken 3 at a time is equal to 20, and then combination of 14 taken 3 at a time is equal to 364. And then since again this can be further simplified, and it should give us a value of 5 over 91. This is now our final answer. Or in other words, the probability of getting 3 red balls out of 14 balls in a box is 5 over 91. Sample 5. 2 light bulbs are drawn at random from 30 light bulbs, of which 5 are defective. So out of 30 light bulbs, there were 5 of them which are defective. Mean to say there are 25 bulbs which are working. And then the question here is that what is the probability that both bulbs are working? So what is our sample space here? That is, we have 30 light bulbs taken 2 at a time. So out of 30, we are going to select 2. That's our number of elements for our sample space. And what is the number of elements for event E? It is both the bulbs are working. So I mean to say how many bulbs which are working we have? We have 25. For out of 25, we are going to select 2. That is combination of 25 taken 2 at a time. And that is our event E. Then from there, compute the probability. Okay, I want you to try answering this problem. Then after which, show your answers, and I'm going to show you my solution. Okay, I do hope you now have your answers. So let me show you my solution for this problem. Again, the first step that we're going to determine here is to find out the number of elements in our sample space. So that is, out of 30 light bulbs, we are going to select 2. That is, combination of 30 taken 2 at a time, which is equal to 435. Therefore, we could say that the number of elements in our sample space is 435. And then the second condition is that getting 2 bulbs which are working. So there are, since 5 of them are defective, so there are 25 bulbs which are working. Then out of 25, we are going to select 2. So that is, combination of 25 taken 2 at a time is equal to 300. So we now have our number of elements in sample space, and then we also have the number of elements in our event E. This is our number of elements event E, and this is our number of elements in our sample space. Then from here, we can now compute the probability of getting both bulbs which are working. Okay, so the probability of getting both bulbs are working is just equal to combination of 25 taken 2 at a time, which are the both bulbs are working, and then combination of 30 taken 2 at a time, since we have 30 light bulbs in all, and then out of 30 we are going to select 2. So combination of 25 taken 2 at a time is equal to 300, and combination of 30 taken 2 at a time is equal to 435. Thus, if we're going to simplify this fraction, it is now equal to 20 over 29. So that is, the probability of getting both bulbs are working out of 30 bulbs is equal to 20 over 29. Questions so far or clarifications? Again, the first step, you have to determine the number of elements in your sample space, and then the second step is to determine the number of elements in your event E. Questions so far or clarifications? If there is none, let's continue another problem. For the same problem we have, but different situation. This time, what is the probability that both bulbs are defective? Okay, I want you to try answering this problem and then share your answers after getting the solution. And after which, I'm going to show you the solution for this problem. Do you know how to do your answers? Okay, let me show you the answer for this problem. To do this again, you have to find out the number of bulbs which are defective. In a given problem, there were 5 bulbs which are defective. So out of 5, you are going to select 2. So select 2 defective bulbs. So that is combination of 5 taken 2 at a time is equal to 10. And then the number of elements in our sample space is equal to, as I mentioned earlier, that is equal to combination of 30 taken 2 at a time is equal to 435. That is 10 over 435. And then to simplify, the final answer here is equal to 2 over 87. Questions so far or clarifications? Okay, let's try next slide. The same problem we have, but this time, what is the probability that one bulb is defective and the other is working? I want you to try answering this problem, after which I'm going to show you the solution for this problem. So in how many ways can you select one bulb which is effective out of 5 bulbs and one bulb out of 25, then divided by the number of elements in your sample space? Okay, let me show you the solution for this problem. So to do this, you are going to select one bulb out of 5 defective bulbs and one bulb out of 5 working bulbs, divided by a combination of 30 taken 2 at a time. So this is for our defective and this is for our working bulbs. So combination of 5 taken 1 at a time is equal to 5, and then combination of 25 taken 1 at a time is equal to 25, and then combination of 30 taken 2 at a time is equal to 435. Then by further simplifying, that is equal to 25 over 87. Okay, questions so far or clarifications? Okay, if there's none, let's try to take a look on the standard deck of cards. Okay, so we have 52 cards in all, of which from the 52, 26 are black and then 26 are red. We have heard 4 ace and so on, like 4 kings, red and then black cards. Now I want you to consider this problem. For example, suppose that 5 cards are drawn at random from a standard deck of playing cards, what is the probability of getting precisely 2 aces? Okay, we are going to obtain 2 aces exactly. So I want you to try solving this problem, and after which I'm going to show you the solution, how we can solve this. Again, the first step is to determine your sample space. So how many cards are there in all? We have here 52. Then out of 52 cards, we are going to select 5. That is, the number of elements in our sample space, or the number of elements in our sample space will be combination of 52 taken 5 at a time. So that is your number of elements in your sample space. Then the second condition is that there should be 2 aces that you can select. Then the rest are none, or the rest, or the other 3 should not be ace. Okay, do you now have with you your solution? How many aces do we have? And then how many are we going to select? And then the remaining cards, how many are the remaining cards which are not ace? And how many of which are we going to select? That should give you the idea on how to solve this probability. Again, the number of sample space will be how many cards are there, and then how many cards are we going to select. It is combination of 52 taken 5 at a time. And then for the event E is that how many aces are there in all, and then how many of which are we going to select. So that is, there are 4 aces, then we are going to select 2 times how many aces were left after all those 4 aces will be removed. So there is now 52 minus 52 minus 4, it is now equal to 48. So out of 48 cards left, how many are we going to select? It is, out of 48, we are going to select 3 more, because 2 should be aces. So that is your event E. Event E, and so on. Okay, I guess you now have your answer, and let me show you the solution for this problem. And the first step is to, again, determine the number of elements in your sample space. That is, we have exactly 52 cards in a standard deck of cards, and then out of 52, we are going to select 5. That is 52 taken 5 at a time, which will give us this value. It is 2,598,960. And then getting exactly 2 aces is that in a standard deck of cards, there are 4 aces. And out of 4, we are going to select 2. That should give us combination of 4 taken 2 at a time. So 5 minus 2 is we have 3. Okay? These 3 other cards must be taken. Should not be an ace card. Therefore, 52 minus 4 ace card, which will give us 48. Then out of 48 remaining cards, we are going to select 3. That is why we have combination of 48 taken 3 at a time. And then to further simplify, this is now equal to 6 times 17,296, which will give us, further simplifying, it will give us a value of 2,162 divided by 54,145, or over 54,145. And this is now your final answer in lowest form, or in reduced form, or in lowest term. Questions so far or clarifications? So if there's none, thank you class, and have a good day.